Hello and welcome to the sixth and the final episode of Git Series on our channel CloudSewa to Cloud. In our previous episodes, we have discussed the ways how Git merge conflict occurs and the ways to mitigate it, and how to omit those merge conflict errors, and finally compromise and proceed to a successful Git merge. So now we will be talking in this episode about Git cloning, pull request, forking, and resetting and reverting, and stashing and reflogging. So let us get ahead with what lies ahead. So I basically pushed the work we have done in our previous episode. It's about Git merge conflict. As you can see on the screen, we have the remote repository called merge conflict. Now we will be we will try to do how we will try how to clone this remote repository in our local repository. So here we have, and as you can see, there is code. If you click onto that, you're going to get HTTPS, SSH, and GitHub CLI. So I will be copying the HTTPS link here, right here, and then I will be moving on to my Linux machine. As you can see, I have nothing on merge conflict here, so I will be typing it the link, cloning into merge conflict. Okay, counting objects, all done, all done, all done. So it says that it has all done, so let's change on to that tree, and let's see what other branches here. So only the before conflict branch has been signified here. So let's yeah, it is giving you only the before conflict, because if you clone and you have that active branch that you are sticking into in that project, it only sorts you by get branch. And if you do get branch double hyphen all, you're going to see all the inactive branches too. But you can also check out, that's the you can move on to that, and if you do get branch, you can see before conflict and master, it's visible. So you need to check out all the branches for them to be visible on git branch command. Branch A, branch B, and branch manager. I think that's all. So git branch. So yeah, you can see all the branches, and you can move on from one branch to another. You can also log messages, and okay, what has happened here on every commit. So this is the first commit, and okay, you have the entire history here. So that is all for today. So here we have a proper figurative illustration talking about the multiple methodologies that we can move around from pulling a repository, pushing a repository, cloning a repository, or forking a repository. So here you can see in the figure, let's talk about the scenario, and let me get you into the details. So here you have the original creator's GitHub account, and there he has his work, he or she has his or her work, and then you need to pull it, you need to pull or clone it to your local repository, where you'll be doing certain changes to the codes. And once you make the changes to the code, you push it to your GitHub account. So basically, forking a repository is like cloning a repository. It's just the difference that you might have changes with respect to the original content, and the original content might have some changes with respect to the time. So you will take time making changes to the cloned repository and pushing it, and within that range, the repository, the original repository, might have certain changes, and there might be discussions ongoing for the codes and everything from via multiple people all over the world. So forking original repository means you have your changes and also the original created changes, as well as the original content that is identical to yours and the original creator's content. So basically forking an original repository is like that. And um, uh, we can also merge the forked repository to the original repository via pull request. So what does it mean actually? So let me give you a scenario like you have a project of the original creator, and you make some changes to the code, and you face certain bugs in that and you fix it, and you have the fork repository in your GitHub account. And while you give a pull request to the creator, and then he or she reviews the code, and if he or she likes what you did to the bug fixes and what you did to make the changes and alterations in the code, and he or she might take your forked repository and merge it with uh, his or her repository. So basically, talking about cloning, pulling, pushing, forking, it's all, and it's clearer with this diagram and the flow in it. So we now move on to resetting and reverting. So if you ever encounter a problem like you did a wrong commit that made certain changes to your project and introduced you to multiple errors and bugs, and you might want to go to the previous commits, or like let's say you have a bug and you go on debugging on your project, and you use the git bisect, and you find out which commit gave you that bug, and you might want to go rewind and go to that commit and start from there. So there is an option called Git Revert. So basically, Git Revert is to create a new commit which reverts a previous commit. So you can check out the head numbers of your commits by using git log, and git log shows you all the commits history and the commit heads. So once you type git revert and the head, it basically reverts to a previous commit that is done from that commit. So now we move on to git reset. So git reset command also includes option to update the other parts of your local environment with the contents of the commit where you end up. So it's basically you can reset it with either git reset double hyphen shaft and head number, or you can also set it via git reset double hyphen hard head number. So as you can also check the status, what you are going through and what the comments are going through, and by using git status, and you can also check all of the commit logs and histories by using git log. So now let's move on to Git Stashing. In my previous sessions, I've already described you in detail the workflow architecture of Git, where you have the working directory and then the staging area and then the Git local repository where all the committed work are stored, and from that you can push it to your desired remote repository in your desired platform. It might be GitHub or GitLab. So what exactly is Git Stash? Git Stash is a temporary storage location which does not include in either the working area, the staging area, or your local repository. It's a separate one. So what we do is like we can save the unsaved file, but the changes that we make in any of the branches which we are not ready to commit, we can save it in the stash. So when is it helpful? It's helpful when you make some changes in a branch, but you are not ready to commit it, but you need to switch on to another branch. So there it is quite helpful without losing your work you did. So let's look at the screen. Stashing takes the dirty state of your working directory, that is your modified tracked files and stays changes, and saves it on a stack of unfinished changes that you can reapply at any time. So to push a new stash onto your stack, we can write git stash. To see which stashes you've stored, git stash list. So if I do like git stash and something given a file name, what is it actually does is like the changes that has been made onto that file from the latest commit will be stored in the stash and reverting the file to the previous latest commit, and then recording that particular moment. So basically it's just a snapshot. And here, as I've already explained you the working principle of git stash, there might be a complexity that you might face, so let me tell you a scenario about like when you have moved on in a branch and you have that newly created file that does not exist in your latest commit, and you work on that file and you try to stash that file. So basically what git stash does, it just only takes out the changed part and then stores in the temporary location, and then it goes back to the latest commit what you did. So in your latest commit, the file does not exist, but you want to stash the file. So there you probably gonna face a problem. So what you can do is in your latest commit, you create the file and then you do the commit and then you make changes to the file and then you stash them. So that's all for the git stash. Now let's move on to Git Reflog. So what is a Git Reflog? It's basically a mechanism where it tracks all the changes and the stories of data at the tip of the branches. So to be precise, what the tip of the branches means, that tip of the branches mean the latest commit you did on a particular branch, and every time you do a commit, there is the change in data and stories in data. So what Git Reflog basically does is they store the information and data at the tip of the branch. So at your latest commit, if there are any changes in data or informations, it just basically stores everything. So what purposely is required of Git Reflog is that Git tries to give you the safety net to protect your data at any cost. So that you shouldn't be worried about doing a git merge or git rebase and then losing your data. So anything you have updated in Git, like you have committed in Git, there is changes of data and you think you have lost it, you can retrieve it via Git Reflog. So let's look at the screen. Reflog tracks when Git refs were updated in the local repository. Reflogs are stored in directories under the local repositories.git directory. The most basic reflog use case is invoking Git Reflog. Okay, this is essentially a shortcut that's equivalent to Git Reflog show head. To get a complete reflog of all res by executing Git Reflog show all. So basically, Git Reflog gives you the data of latest commits, and Git Reflog show head, it gives you the data of the particular commit that you've done. So that's all for